Hey guys, this is Mr. Drabinski, and in this lesson we're going to walk through how to use the quadratic formula to solve application problems involving quadratic equations and parabolas. So we'll walk through an example of what this might look like. Here's the one we're going to talk about. You have a graph that shows the flight of a piece of paper after it was shot into a trash can. So here's the graph and the x and y axis. The x-axis represents the time the paper has been in the air, and the y-axis represents the height. A little bit hard to see on this paper, but here's the crumpled up piece of paper, and here's the trash can with the bottom of it on the x-axis. So the paper's flight can be represented by the function f of x equal to negative 2x squared plus 5x plus 4. And so the first question asks us to figure out after how many seconds will the paper hit the bottom of the trash can. And the bottom of the trash can is at y equals 0, meaning the height is 0, the height is on the ground, and we're going to apply the quadratic formula to this from our previous lesson. So in this case, you have A is negative 2, B is positive 5, and C is positive 4. And so let's get the correct numbers in the correct place and then simplify. So we'll start with negative, or as I call it, opposite of B. Since B is 5, it's going to start with negative 5 plus or minus the square root of b 5 squared minus 4 times a, which is negative 2, times c, which is 4, everything divided by 2 times a, which is negative 2. And then we'll just simplify it a little bit and then approximate the answer as a decimal. So we have negative 5 plus or minus the square root. 5 squared is 25. Negative 4 times negative 2 is 8. Times 4 is 32. All over 2 times negative 2, which is negative 4. And that's negative 5 plus or minus the square root. 25 plus 32 is, I believe, 57. Square root of 57 all over 2a, or as we said in the previous step, negative 4. And so that is as far as we'll go simplifying it in exact form. So let's get a decimal approximation for this to make it easier to see where this answer is. And of course we're solving it for 0. And that's what our answer will tell us. So let's go negative 5 plus the square root of 57 divided by negative 4. And we get negative 0.637, which I'm going to round to negative 0.64. And then the other answer is negative 5 minus square root of 57 divided by negative 4 is 3.137. I'll make it 3.14. And so those are the exact answers for the x-intercept. Or looking at the graph, we could see, I grabbed a screenshot from Desmos, but we could see that that's what the graph is telling us at 3.137, or as we rounded to 3.14, the graph hits the x-axis, which is, in this application problem, the bottom of the trash can. And then the negative 0.64, since we're talking about time on the x-axis, this number in this case is invalid since time is not going negative. We're only concerned about the positive. So after about 3 seconds, the paper hits the bottom. So the next thing we can do with this is figure out, well, what's going to be the highest point of the paper's flight. So in this case, you can see on the graph, the highest point happens at 1.25 seconds. and it's about 7.1 feet, but let's show that mathematically using the same function. So one thing to kind of remember is that the highest point is right in between the x-intercepts. And so, as we said in the previous step, even though negative 0.64 was invalid in terms of the answer, the highest point is going to be right in between those points. So we're going to take the average of that. So we're going to take negative 0.64 plus 3.14, divide that by 2, and that's going to tell us what's the x value that's in between those two. So we'll go negative 0.64 plus 3.14 divided by 2, and you get 1.25. So that means at 1.25 seconds, the paper is at its highest point, which is valid. Looking at the graph, that's what it's telling us. And so if the x value, remember this is the x value, we also want to find the y value, which is its height. And so if we're given this equation, we know that the x value has to be 120.25. We can just substitute that in for the x. So it'll look like this, where we take negative 2. Instead of x, we're going to put in 1.25 squared plus 5 times 1.25, because it's x again, plus 4. And then from here, we can just put this in the calculator. So we'll go negative 2, 1.25 squared, plus 5 times 1.25. Notice how I'm putting parentheses to show that I'm multiplying that input, which is 1.25, and then plus 4. I would expect the answer that I see on the graph, and that's what I get mathematically. So it's 7.125, 7.13. I'm not too particular about the rounding here, but we should remember to put in units, which is feet, since we're working with an application. So the highest point of this paper, based on the model of its flight, is 7.125 feet. And then finally, to conclude this problem, we're asked to find after how many seconds will the paper be at a height of 5 feet. Again, looking at the graph, we can see that 5 feet is this horizontal line right over here. So we'd expect maybe just past 0 seconds, maybe 0.1, and then it goes up and then comes down, and then on its downwards flight, it looks like it's close to maybe 2.5. So let's show mathematically where the exact answers are. So we'll take the same equation, remember f of x represents the output. So we're basically looking at finding where is the output, where is the y value 5. So we can take this function, for the flight of the paper, and set it equal to 5. So we'll have 5 equal to negative 2x squared plus 5x plus 4. And one thing that we mentioned in the last unit is that the other side, the side that doesn't have the x squared, that should be 0 in order to solve, and we can make that 0 pretty easily by just subtracting the constant from both sides. So that'll be 0. That's still negative 2x squared plus 5x, but now our constant is negative 1. And then we can repeat the quadratic equation again with this expression. So we'll go A is negative 2, B is 5, just like last time, but now C is negative 1. So let's see how that affects our final answer. Negative B, so quadratic formula again. Have it handy to reference in case I don't remember. but negative b, so negative 5 plus or minus the square root of 5 squared minus 4 times negative 2 times negative 1 all over 2a, which is 2 times negative 2. And let's do a little bit of simplifying. So negative 5 plus or minus the square root. And this is going to change our answer compared to our number 1 where we got square root of 57 because the negative 1 changes things. So 5 squared is 25. But now we have negative 4 times negative 2, which is still 8, times negative 1. This time it's going to be minus 8 over negative 4, which becomes negative 5 plus or minus the square root. 25 minus 8 is 17, but we can confirm that. 25 minus 10 is 15, plus 2, 17. A little bit of mental math, but 17 over negative 4. And then, just like we did in number 1, let's get the approximate answers. And in this case, I would expect, again, looking at the graph, that both answers would be positive since it's at 5 feet here and here, which are both in the positive x direction. Let's confirm that. Negative 5 plus square root of 17 divided by negative 4. So one of my answers is 0.219, which I'll say 0.22. And the other answer is going to be negative 5 minus square root of 17 divided by negative 4, 2.28. 2.28, and both of these are in seconds. So looking at the graph, it does make sense that this is about 0.2, and then again we're at 2.28, so we're closer. At this point we're closer to 2 than we are to 3, so again that point seems to be valid on the graph. I could always plot this in Desmos and then drag over to see where at 5 what the answer is to verify, but these should be the correct answers. So that's the idea of applying the quadratic equation to solving different aspects of a quadratic application. So for the practice, you guys are going to do 3 of these types. The first one is again a paper throwing problem. The second one has to do with, I believe, a rocket. And the third one is going to do with shooting a basketball. There's an activity in Desmos called Application of Quadratic Functions Visual Examples, where you'll be able to use sliders to actually drag the paper or drag the rocket, and as you drag you can form the equation, the graph of the equation, to see how it develops, and that's going to be a way you can check your answer. So it says use slide 2 of the Desmos activity to solve. You'll see that in your student's dashboard, but when you go to slide 2 you'll see a function that's g of x equal to negative 2x squared. It's not negative 2x squared, it's negative 3x squared plus x plus 6. And so you're going to use this equation like we did in the example to solve different parts of this application problem. To just kind of help you get started here, remember that a would be negative 3, b, since it's plus x, the coefficient here is 1, and then c is 6. So it asks you to find, again, the bottom of the trash can, the highest point, and when will this be at 5 feet. Very similar, exactly similar to what we did, just with a different function. And then, like I mentioned, 2 and 3 is a rocket and then a basketball. So give it a try. If you guys have any questions, feel free to hop onto office hours, and I will catch you next time.